Everybody, welcome to another exciting episode of Data Exposed. I'm your host, Scott Klein, and with me today is Borko from Serbia, correct?
Yes.
And it's good to have you in studio because last time we did a show with you, we had to do it over Skype because you were recording from home.
Exactly.
Right? So it's actually good to have you in studio. So take a second and introduce yourself.
Thank you, Scott, and thanks for inviting me. So my name is Borko Novakovic, and I'm a program manager in SQL Server engineering team. My team is located in Belgrade, Serbia.
Okay.
And I was working on Temporal, a new capability that is coming in SQL Server 2016 and Azure SQL Database.
Sweet. So we're going to talk about, so you and I were chatting before we actually recorded about what Temporal is, and this is actually really exciting. So I'm excited, and hopefully our viewers will be excited about what Temporal really is. So why don't you give us a quick introduction into what Temporal is, and then we can jump into some demos.
Yeah, of course. So, before we start discussion, why would people use this new feature? Actually, let's spend some time explaining what it is.
Yep.
So, temporal data is type of the data which is actually tightly related to time context, to time dimension. And every record in temporal table is actually considered to be valid or true only within a period of time that is assigned to that record.
Okay.
Now, temporal database has capability to answer some very interesting questions, like how your data looked like a year ago, and what was the evolution of the data in a period that you are interested in.
Yeah, so this gives us an idea as to, hey, what did my database look like?
Yes, exactly.
4 months ago.
Yes.
A year ago.
Now we can understand why people would use this feature, because business users especially are very interested to understand the trends and type of changes and the data evolution.
Yep.
But traditional databases fail to support these kind of scenarios. And actually, this is where SQL Server comes into play to solve that situation and help all people that actually want to effectively handle time varying data.
Yep.
We really think that this is a generally useful feature. It can be used in many different scenarios. Let me give you a couple of ideas how you can utilize this feature. Like, probably the first and the most important scenario is adding a time travel capability to your existing application. What does it mean? It's actually ability to reconstruct the state of the data as it was at any point in time, or to compare multiple points in time side by side in order to draw some conclusions, right?
Yeah, so basically we're talking, when you say time travel, we're talking really about going back in time to say what's the state of our database, right, some time ago, or doing a comparison between that period of time and today.
Imagine, yes, exactly. Imagine an important business report.
Yep.
You are generating that report today, but you also want to understand how that report exactly looked like 6 months ago, because you want to see trends and the type of changes. And with Temporal, you will get that for free.
Right. Yeah. So just remember, you heard it here first. SQL Server 2016 introduced time travel.
Yes. Some other scenarios will benefit, like data audit. Temporal is really designed to simplify data audit. It really tracks all changes that happen in your database. And also, like designing and maintaining slowly changing dimension will be very, very simplified. And finally, DBAs and data quality officers now have a new tool to do repair in case of accidental data corruptions made either by humans or applications. Why? Because every record in a table has full history of changes assigned. You can go in history, pick the version that was correct, and just with a simple update correct the current state of the data without dealing with backup, restore. Your database is always online and highly available.
Right. Oh, perfect. Okay.
Yeah.
So it helps kind of clean things up. Like you said, if a record gets corrupted for whatever reason, I can go back and say, well, I know it was clean at this period of time. Go back and restore that.
Yes.
Right. That's kind of cool.
Yes. Now, how people can use Temporal, right?
Yep.
So it's a new type of table. So. Which means that people have two options, either to create their new objects as temporal objects, or even to extend existing schema with temporal capabilities. And we provided very flexible DDL syntax for both scenarios.
So that's an interesting concept, right? So I can take an existing, so I can either start new and create a new table as with temporal in it, or I can take an existing table and say, hey, I now want to make this existing table temporal as well.
Yes,
right?
yes.
Okay.
And history for that table will be built from that point on, right?
Right, okay, yep, okay.
The most important thing, once you create or actually convert your existing tables to temporal ones, you will continue using them in a pretty much same way you are doing with the regular tables.
Yep.
No changes in DML, no changes in regular querying. This is very convenient for introducing temporal in existing schema because it's a really frictionless operation. But now you have new capabilities because you can answer some new type of questions that you haven't been able before, right? Which means there is a syntax extension related to temporal which allows you to answer 4 type of questions like as of, from, to, between. I'll talk about these later.
Right. So this allows me to get better insights into my historical data, right?
Yes.
Okay.
Yes, definitely.
Cool.
Now,
oh, it says new insights.
yeah, new insights, right. So this is how temporal works. In an essence, it's a system that consists of 2 tables.
Right, okay.
The primary one, the temporal one.
Yeah, either new or an existing table,
yes,
like we talked about. Yep.
It contains only the actual data.
Yep.
But there is a history table attached to the primary one, which is there to store all historical changes that happen in your table.
Okay.
So here is how you will interact with the temporal table from your application or from your script.
Okay.
You're always interacting with the primary table, with the current one.
So I'm not talking directly to the temporal historical table.
Yes, you don't even I
don't even care it's there,
yes,
right?
Yes.
Yeah, okay.
So actually, as I show, like when you insert the data into the temporal table, it actually it is in the current one, right?
Yep.
But every time when you update the record, what
Yep.
happens? SQL Server automatically, transparently for your application, moves the previous version of the record into the history table
okay.
and attaches the timestamp when that operation happened.
Okay.
So with that, actually, data repository now you can answer different type of questions. Of course, you can ask about the current state of the data as you did so
what was
far.
this record as of this time frame? Or,
yes,
right?
But if you are using these new temporal querying capabilities like time travel stuff as of or
Yep.
what will happen, SQL Server will transparently rewrite your query and include history table behind the scenes in order to produce the correct result.
Yep. That's okay. That's pretty slick. So I can execute queries. Now I'm actually querying when I how do I say this? When I type in a query, I'm not querying directly against my temporal table.
Yeah.
I'm still hitting this, but
Yeah.
based on the query extensions, it may be pulling data from the historical table.
Yes.
Right,
And
okay.
SQL Server decides whether to include history table or not. It is smart enough to exclude history table when it's not necessary and to include when it's really necessary.
Yeah, so I'm just writing, again, I don't have to care that table's there, right? It's there. I'm just writing my standard query statements. And if it needs to, it'll pull that data from the temporal table.
Yes.
Historical. Okay.
So I had 2 examples to show you how temporal can help with some interesting scenarios.
We love examples and demos.
Yes.
All right.
So this demo is about one application that has time travel capabilities. This is the application that I built on top of SQL Server 2016 using the temporal, and I want to show you how simple it is to build this kind of application.
Excellent.
So this is the application that shows me the organizational chart of my company, right?
Okay.
And if I'm a manager who is involved in company growth planning and stuff, not only that I would like to see the latest state of my org, but I would like to understand how my organization looked like when it was established, how big or small it was.
Right, okay.
And this is actually, this application is magic one. It can help me go back in the past and see like when, how my organization looked like. Now, if I go 2 years before, you see, I can get very simply the insight.
Okay.
And not only that, I can, as I mentioned, I can compare any point in time side by side. Like this is the insight that I'm getting, how my organization changed in last year.
Okay.
I updated some department, some location. I also opened some new location. This is what I can get.
This is fantastic. Right.
Yes, and like I can tell you that like writing this application was really easy and fun, and I will show you why it's easy.
Easy and fun. We like easy and fun as well.
Yes. So let me go to Management Studio, and I will show you the data access layer for this application.
Okay.
So this is the like regular view. It just joins 3 tables. Like I have location, I have departments, and I have table which is a relationship between those 2, right?
Yep. Okay.
So nothing specific about this view. This is the view that we would write for any other type of application.
Sure.
It's a simple
standard.
one.
Yes.
Standard view, right? But yet this view is a secret ingredient, because when you query this view using the standard syntax, of course you'll get all the data, right?
Yep.
This is what we have in the first screen.
Yep.
But this view can be used with these temporal extensions, right?
Yeah.
In that case, it becomes a kind of a, let's say, time machine. Now I just change the parameter for this query and I go to any point in time very, very transparently.
So you basically said, give me this date, give me the same information. So this really, if we compare the two, all you changed was for system time as of.
Yes.
That's all you
Yes.
included, right?
Yes.
And at that point, SQL Server said, go back to the historical table and get the data for this.
What
right?
is beautiful here, this is a view.
Yeah.
What SQL Server is doing for me, it goes inside the view, it searches for all tables that are temporal and applies the filter to every temporal table. It ignores non-temporal tables. You can have an
sweet.
arbitrary complex view that relates both temporal and non-temporal tables, only temporal will be affected. The entire data model is just moved. Your
Yep.
focal point is actually moved to any
Yeah.
point in time.
That's-
Now you can see how comparison between 2 points is very simple. I have a view and I have a view as of, and this is, if I execute this query, I'll get the difference between those two.
Right.
Let me show you what SQL Server is doing for me with this query. All kind of a different query rewrites,
Yeah.
access to history and current table happens behind the scenes. I don't even need to take care about that, and this is the
Right.
beautiful thing. Now, in order this to work, what I need to do? The only thing that I need to do is to create my table as temporal one, and there is a syntax. A regular table, create table syntax.
Yep.
The only two things are specific, two temporal attributes we call them. This is a period definition. It consists of 2 additional columns and reference to history table where all changes will be stored.
Okay, so yeah, and this is kind of interesting, right? So this we know standard create table statement, but right, this is this is standard.
Yes.
This is the only thing that's different here
Yes.
from the define basically saying, hey, define my historical period for this time frame, right? And then you're saying store my historical table here. So the question I have, I've got several questions. Does it automatically create this table for me? If I execute this statement, does it automatically create that
There
table?
are many
for me?
options for you. If table already exists, and this is the case when you want to migrate your history,
Yeah.
it will just attach the newly created table with your history, and you will continue capturing new changes. But if table doesn't exist, SQL Server will create one for you.
Okay.
Yeah.
And another question. So I noticed, when I first looked at this, right before I noticed DBO, so schema here, and then this has a history schema. Why the two different schemas?
It is flexibility for you. You can actually, when it comes to history table, you have many flexible options.
Okay.
You can even use of course, what you noticed, you can have it in a different schema. Sometimes that can be usually useful because
Yep.
you want to distinguish between the current and history tables.
Yep.
You can organize in them. You can have different security permissions
Right.
and stuff.
So I don't have to put it in
Yeah,
different
of course,
schemas.
you don't have. It's just a flexibility
Okay.
that you have. But you can also combine different storage types. For instance, what people may find very, very useful and convenient, department table can be regular disk-based table or row store. But department history can be column store, cluster column store.
Oh, yeah,
Because of the
okay.
compression and everything, and different type of
And
querying
if-
that you are using.
Yep.
So
And if I'm doing a lot of historical, query things like that, I may want the performance out of that, right?
yes.
Yeah. Okay.
So this is the flexibility option that you have here.
Yeah. Yep. Okay. And we talked about this before, right? If I want to make a schema change here, right? Because I noticed that this says the word caught my eye on, right? So if I can turn something on, I can turn it off.
Yeah.
I would assume, right? So if I want to make a schema change here, how does that? Do I have to? Is the schema automatic to here, or what do I need to do to make a schema change here, and how does it reflect into my history
This
table?
is a great question. So while system versioning is on, schema changes are blocked, which means you cannot really change the schema. But there is a path for you in order to do that. If you are admin, if you have permission, what you need to do is to there is an alter table statement which says alter table department set system versioning off. Then you can perform changes on both tables independently. And again, there is a alter table statement with system versioning again on. In that state, SQL Server checks whether the schema of history aligns with the schema of the current table. And not only that, you can also have a data consistency check, which actually is preventing you from inserting overlapping stuff that wouldn't be consistent from temporal point of view.
So to make a change, I got to turn this off, make the change in both, so 2 separate statements, and then turn this back on.
Yes.
Right? And then there's consistency checks, like you said, from the data, right?
What is our recommendation is to do that as part of the user transaction. So you can say begin transaction, alter department, set system versioning off, change your tables, and then system versioning on, and commit transaction.
Yep. Okay.
This is an isolated way to isolate it. Right.
Excellent.
Yes.
Okay. Good. Which is very simple, right? I like the fact that you're not making it really hard to on many levels, right? You're not making it hard to make changes here, right? If I want to take an existing database, I'm just basically doing an alter table department, right?
I can show you, actually. I have a second example is about that, right? So the first
Even better.
the first example was how developers can benefit from Temporal while they're building new powerful application.
Yep.
But the second example is actually about DBAs, and this is what you mentioned. So imagine I have a requirement to start tracking all changes in my AdventureWorks database. Person table is very important for me.
Okay.
I want to understand, I want to see how data changed in person table. What I need to do, I have alter table path, as I said. It contains of adding the period definition here and reference to history table. When I do this, actually none of my application will be broken. They will continue to work. Why? Because they do not need to know that this happened.
They don't care, right?
Yeah, they don't care. They don't handle these columns, right?
Yeah.
And I can show you, like, this is the existing store proc that updates the person, and I can use the statements and everything. So if I issue this, actually what will happen, updates happen, right?
Yeah.
Transparently, everything goes. But I now have a between and end type of query which says, what are the changes that happened to my records of interest, right? If I run this query, I'll be able to see all changes, right? So for the business entity ID, the previous version of IMO promotion was 0, now it's 2. Title for 7 was empty, now it's set, right? So I can perform the data audit, right? And what's important, I can also correlate the output of this query with regular SQL Server audit functions and views in order to attach the information, who changed the row, what was the principal, when the change happened, and stuff like that. What was the original statement?
Yeah, exactly, right. And again, this is the time travel comparison type of scenario, right? And I love the fact that if you go back, to make these changes was just a few lines of code. Right?
Yes.
And again, the fact that, the developer is completely unaware that you made these changes, but he can still, same queries, right?
Yes. And if any point in time you don't need the temporal capabilities, again you have a path to remove, to drop the link between the current table and history table, to remove the period, and you can decide what you are going to do with the history data. You can archive the history data, or you can even drop the history if you don't need it.
Go back to your queries for a second, because I think, when I said that, something triggered my mind, because, we're saying, let's see. Okay, yeah. So they really didn't change their queries here in this case, right? This is probably the same queries they might have had in their application. They really didn't change anything, right?
So, when it comes to existing queries, nothing has changed.
Right.
If you want to extend your application to leverage the fact that tables are temporal, you need to actually extend your querying with this for system time clause.
Yeah. Okay, and that's what I was looking for, right? Yeah. So they may have to modify their queries just a little bit, right?
If they want to have temporal insights.
Triple insights,
yes,
right.
Yes.
Okay.
But what is flexible? This clause is assigned to a table. You can have a very complex query with multiple temporal tables. Every one can have independent for system time clause attached to it.
Okay.
So you can compare multiple temporal tables with across different points in time. Which is really an awesome.
Yeah, that's good to know. Yeah. So what I don't want to do is set expectations that several things, right? So I can make the changes to the database. Developer doesn't care, right? But if they want to start taking advantage of the temporal, the for system and the betweens, things like that, they may need to make changes to their queries, right?
Exactly. But this is completely decoupled from the altering the schema.
Correct.
This is
completely
another
decoupled.
step, right?
Yes. Yeah. So 2 steps, right? One doesn't affect. The architecture change, the schema changes don't affect, won't affect their application.
Yes.
But if I want to take advantage of the temporal, right, capabilities, I will need to modify my queries, or may need to modify my queries.
So I just want to say that when it comes to altering the schema, what is not shown here but will be available very soon is ability to specify these new columns as hidden ones. And that will completely hide them from any attempt.
Oh, that's good to know. Yeah.
They won't appear in select star statement. Any kind of update insert statement that we're using basically won't be affected by this. So this is coming.
Okay, that's good to know. So right now this is in CTP2 of SQL Server 16, right? And when we talk about cloud first, right? We always talk about cloud first. So this will be coming in Azure SQL Database, right? In
Very, very soon.
Very, very soon.
Yes.
Okay,
very
good.
soon.
Okay, perfect. That's good to know, right? Awesome. All right, this is excellent. I think this is, because there's been a need for Temporal for quite some time, and it's good to see this here. And this is, what you've done is you've made it very easy to use, which I think people will like, right?
I believe, yeah.
Yeah, good. Now, so if they have any questions or feedback, what's the best way to get in touch with you?
So I actually, Temporal is part of the CTP program, like top preview program, so people can contact me directly. We have Yammer group, but of course they can contact me using the social network like Twitter and stuff.
Okay, perfect.
Yeah, that's really.
All right, we'll be sure to put that in the show description.
Yeah.
Awesome. Berko, thank you so much. This is fantastic.
Thank you.
This is really good. So everything. Appreciate your time, Berko. Thanks for coming, and everybody, thanks for watching. We'll see you next time.
Thank you. Bye.